Hello, welcome to the first informational workshop for geology. This informational workshop will cover Chapter 1 from the Earth 10th edition. The title of the chapter is Introduction to Geology. During this informational workshop, as with future informational workshops, we will be covering the content in the chapter. We'll also cover some additional important information for you to know. And each section of the informational workshop will have a few formative assessment questions, quick mastery checks, for you to check and make sure that your understanding is as deep as it should be and that you know the vocabulary that's pertinent to each section of the chapter. So welcome to the section, and let's get started. You can follow along with the slide deck separately if you wish to view the slide deck on the course web page, or you can just watch the slides as I click through them and explain them to you here in this informational workshop. We'll discuss important things on each of the slides, and you'll need to be taking notes as we work through the slides. Remember, you have copies of the slides in your packet with spaces next to them to take notes on. Please have those ready. We'll begin in a moment. Chapter 1 begins by introducing us to the concept of the importance of geology to not only the environment of the Earth, but also to the societies that live on the Earth, to the people. And so in this slide, we're asked to think about what some of the natural hazards are that are geological in nature and how they impact people. So what kinds of examples can you come up with? Let's start with the examples shown here in the slide. Easy example on the right side, and one that we're frequently used to seeing in our Chicagoland area, is the example of flooding. After heavy rains throughout the year, in this picture you can tell that it's spring or summer because there are leaves on the trees, the grass is green. Some of the streams or creeks, lakes, or ponds in our local area may overflow their banks. This is as a result of heavy rainfalls, high amounts of precipitation that occur in a short period of time. From this picture, you can see that this flooding event has impacted some people who have a car stranded upstream here on the roadway. You can also see that some of the power lines are in an area that is flooded out, that the roadway is closed because it is flooded out, and some adjacent fields or yards are also flooded. How many times have you seen this happen in our local area? Take a minute here to jot down the impact that any flooding events that have happened in the last couple of years might have had on you. You'll want to write those on your notes section of the page next to this slide. I'll give you a minute to do that. Let's turn our attention now to the top left picture. This is a picture that was taken following the earthquake in Haiti a couple of years ago. We would remember from many news stories over the past couple of years how dramatic the impact of that earthquake was on the country of Haiti, the island of Haiti, and how it's still impacting that society today. Here in this picture, you see the remains, the rubble, of buildings that were knocked down during that earthquake. Make some notes about how you think that earthquake impacted the people that you see here in this picture. What would it have been like to have lived through that earthquake? What challenges would you and your family have faced immediately following that dramatic event? And down the road, several months or even a couple of years later, what challenges do you think the people of Haiti are still facing as a result of that single event? Now you're getting a feel for what some of those impacts are that are geological in nature and how severe they can be. The bottom picture in the center, I bet you recognize. That's a picture of some cleanup work that was being done in the aftermath of the tsunami and earthquake in Japan. Again, you'll want to take a couple of moments here to jot down some of your recollections of news stories that you heard following that earthquake. What happened as a result of the earthquake? Remember the incident with the nuclear power plant that was close by that earthquake epicenter? What concerns did they have? What was the impact of the radiation that was leaked from that nuclear power plant? How broad-reaching was that impact? Did it impact agriculture in the area? What other impacts do you remember hearing about on the news? I'll give you a moment to write some of those things down in your notes. So let's take a look at a slide now that summarizes what some of the impacts are when one particular thing happens of a geologic nature. What happens when sea level changes? So we can see a picture here that shows us some information about different sea level changes and which cities might be flooded. And at the bottom we have some information. It tells us that in 2008, more people lived in cities globally than in rural areas, and that those cities are concentrated in areas that are prone to natural disasters, such as being near coastlines, near major faults, or near volcanoes. But for a minute, let's focus in on what happens when sea level rises. Let's take a look at this image. Let's really dig into this image. And as we do this throughout the year, I'm going to encourage you to treat images like this as a simple XY graph, because that's what this is. So initially, let's consider what the y-axis is showing us. If you look at the top left corner of the picture, you'll notice that it says years and sea level. What this graph is suggesting to us is that over time, from the present day until 8,000 years from now, sea levels may increase anywhere from 1 meter to 80 meters. Now, if you take a look at the right top corner, you'll see a picture there that shows a map of the world, and in the dark shading, you'll see the continents 8,000 years from now, or what's left of them, what's not underwater. And if you look down towards the bottom right corner, you'll see 800 years from now what the coastlines and the continents are predicted to look like in terms of what is and is not above sea level. And then more of a current picture about 80 years from now in the bottom right corner. You'll also notice on the far right that there's a list of total contributions. So what's happening in the global environment that is causing these particular changes in sea level? Let's start in the bottom right corner. It tells us that we have already begun this cycle of sea level rise, that in fact, sea level has already increased by 20 to 40 centimeters. Moving up between now and the next 800 years, what will continue to happen that will increase sea level by about 1 meter per 100 years is that the oceans will continue to heat up as the global climate continues to heat up, and that heating will cause an expansion of the ocean levels, which will result in 1 meter per century of sea level rise. Above that, you'll see that the West Arctic ice sheet will add another 6 meters of sea level rise to the system. The melting of the Greenland ice sheet, the complete melting, will be accomplished by about 1,000 years from now and will add an additional 7 meters to sea level. And up in the top right corner, the final melting of the Antarctic ice sheet, or the South Polar ice masses, will add an additional 61 meters to the rise of sea level, which will bring the total rise of sea level to 80 meters over time. Now, the interesting thing to look at is which cities will be impacted by these sea level rises. So if we move back down to the bottom left-hand corner of this illustration or this graph, we'll notice that the city of Venice in Italy has already been impacted. There are many days in Venice when they have to bring out wooden boards and put them across the sidewalk so that people can walk in the areas that are flooded. The next cities projected for impact because of their low elevations are cities like Los Angeles, California, Hollywood, California, Amsterdam, and then Hamburg, St. Petersburg, San Francisco, and even lower Manhattan. These sea level rises may impact these cities. In other words, these cities may not be inhabitable in the next 200 years because of sea level rises of around 3 meters. You can continue to look at other cities that will be impacted by sea level rises in the future. Think about what other places other than these major cities might be impacted by these sea level rises. How are these sea level rises going to impact you? Are there products that come from those areas? Do you have family in some of those cities or regions that are going to be submerged under the rising seas? Take a moment here to write down some of your thoughts about these possible sea level rises. We have one last thing to consider here before we move on to our first quick mastery check. And that is natural hazards that are of a geologic nature impact humans. But we can look at the flip side of this as well. So let's think about what ways people impact geologic processes. Are there things that we do, things that society does, that in turn cause changes in the natural environment? We have some pictures here that we can consider, and I'd like to start at the top right corner. We have two pictures here taken from an airplane, and these pictures are taken of the same location, but they're taken several years apart. The picture on the left, as you can see, was taken in 1987. The picture on the right, as you can see, was taken in 2006. There is one major change that happened during that time. Look carefully at the pictures. Compare what you see in the 1987 image to the 2006 image. I'm hoping you can spot that one major change that the humans living in that area caused. I'll give you a minute to think about it. I hope you saw that between 1987 and 2006, a dam was built across the river. And the effect of that dam being built was to create a lake upstream of the dam where previously there had been a river. Now, we don't know where this area is, and we don't know the purpose for building the dam. Were they looking for a supply of electricity, harvesting hydroelectric power from the river? We don't know that, but we can see the impact of that dam on the natural environment. What happened to the area upstream of the dam between the time it was constructed and the picture on the right, 2006? What happened to the areas that were flooded? What's happening along the new coastlines? And what has happened downstream of the dam? Is there now a large city being built? Has there been a canal added? Take a moment here to write down some of your observations of what happened as a result of that dam being built. I'm hoping that as you're doing this, you're starting to think about what you can learn by looking at pictures. What can you learn looking at images like these and making observations from images? There's a lot we can learn and discern from things that we see in these environments. And it's important to write down the things that we observe as we're looking at the images. Let's move on to the picture in the bottom. In this picture, you can see some miners working in an area in Africa known as the Democratic Republic of the Congo. And when we get to the unit on mineral resources, we're going to be talking some about what's happening in the Democratic Republic of Congo. But in this image, you can see the impact that these people have had on this particular natural environment. Think about what this hillside might have looked like before it was mined. Would it have looked like this? How would it have looked different? Take a moment to write down some of the things that you think might be changed because of the mining operation that's going on this hillside. Now take a minute to think about what would happen if a heavy rainstorm came through this area. What would have happened in the past when the hillside was perhaps covered in vegetation? And how will that be different today because of the clearing that they have done of this land? Speaking of clearing of the land, let's take a look at the picture on the top on the left. In this picture, you can see a forested area, forested region, either being cleared or being impacted by a forest fire. Now think back to this past summer and think about the news stories from Colorado and other portions of the world where there were major forest fires. Many of those forest fires resulted from careless campfire use or other impacts of humans. I think we're ready now to take our first mastery check. So let's take a look. As you're going through any of the informational workshops, you'll want to stop often and think about the things that you are supposed to be learning from each of the slides. Think about any particular vocabulary words that you might know or that you might want to jot down definitions for. And then answer the quick mastery check questions or do the tasks that are suggested on the mastery checks. So let's look at what we have here for our first couple of slides. It's important that you can list and describe at least 2 examples of natural hazards that are geologic and that impact the course of human history or civilization. It's also important that you think about ways society impacts the earth and environment. Describe at least 3 ways that we impact the earth and the environment. Most importantly, can you propose some solutions that would make sense to help limit the impact that we have on our natural environment? Don't think about things far from home. You don't need to do that. You can think very close to home, things that happen in our everyday world. I'll give you a couple of minutes to think about those and to jot down your answers. We will be talking about these in class, so make sure you do a good job on this. Welcome back to the second part of the informational workshop for Chapter 1, An Introduction to Geology. You'll recall that last time we talked about impacts that society can have on the earth and on the natural environment. We also talked about impacts that geologic hazards or processes can have on societies. Today we're going to talk a little bit about natural resources. And I want to give you a little bit of a preview of what your mastery check is going to be. As we're going through these slides, think about some natural resources that you use in everyday products. Think about things you use every day. What are they made of? Which of those components of those items that you use every day have a geologic nature? Which of them come from the earth ultimately? So keep that in mind as we go through this. Before we move on with this particular slide, I also want to suggest to you a couple of other things that you'll want to include in your notes as you go through each of the informational workshops this year. You want to devise a solution so that as you hear new vocabulary words, you can either write them down, highlight them, circle them, do something to make them stand out so that you know that you can go back and look at the definitions of those words in the context of the material as it was presented. I think what you'll find as you start to learn about geology is that if you learn the vocabulary, it will be very easy to understand each of the processes that we're talking about. Vocabulary is really quite a key to understanding geology. So I encourage you as we go through these slides today to start to think about the individual words that you're hearing and learning and making special effort to highlight them in some way so that you can go back and review them again. Another thing about this particular chapter is that this chapter is very much an overview of much of what we're going to be studying throughout the year this year. So the section that we're going to cover today, the section on natural resources, is actually a section we'll be spending several weeks on later this fall. It's really important that you get a good understanding of the importance of some of the natural resources to societies in order for you to understand the chapters that we'll study between now and when we study natural resources. So let's get started on this. The question here on this first slide is an important question for us to consider. What are some of the important natural resources that society uses that are geologic in nature? Now, I know living in the Chicago area that we often take for granted our water supply. But the picture here on the left side shows some people for whom water is not a readily supplied commodity that they can take advantage of. In fact, throughout much of the world, most people do get their water from the groundwater system and not from lakes as we get our water from Lake Michigan or even rivers. Most people rely on water that flows underground, and they rely on wells such as this well shown in the picture. Many people have to walk several miles each day to get water just for the day. And when they get that water, it may not be high quality. It may not be free of bacteria. It may not be water that you or I would want to drink. Water is something that we very much take for granted living here in the Chicago area, where we have a ready supply available to us. Just turn on the faucet, there it is. Water is a resource that is geologic in nature, that is short in supply, and we'll be talking about it later this year, especially when we talk about groundwater in the spring or late winter. Other things that are shown in this picture, in the center, you can see some drillers working on an oil rig. Now, you might get the impression just taking a look at this picture that this is hard work. They've got hard hats on, they are muddy, they are standing in wet mud, and they're doing a lot of hard work here. We know that oil is in short supply. We also know that the impact of burning fossil fuels is devastating our planet. We need to consider this as a society. These are issues about natural resources, the supply and the impact that supply has on society, and we'll continue to consider that. In the top right, you can see a picture of a strip mine where they're extracting coal from a region of the Appalachians. Now, we'll be talking also about coal extraction when we talk about natural resources. What's the primary use of coal, especially in the U.S.? Do you know? Take a minute to think about it and jot it down. The picture on the bottom right is another coal mine. This is an underground coal mine as opposed to a strip mine, which is a surface mine. When we talk about natural resources, we will talk about the different methods of extracting different resources. Let's take a look at what some of the other resources that we use are. There are a lot of them, so get ready. Here we go. This is an important slide to look at in light of your mastery check coming up. So think about the question. Which natural resources are contained in products that you use every day? Here we're saying, which natural resources listed here do you recognize and know the uses of? Take a close look. What we're seeing on the left side is we're seeing the name of the metallic equivalent of the natural resource. So you'll recognize things here like gold and silver. Maybe you recognize things like tungsten or tin, nickel, lead, copper, sulfur, iron, coal, petroleum. But look at the very bottom. Sand and gravel? Really? What are some things that sand and gravel are used for that would cause them to end up on this chart of natural resources? Jot down a couple. I think you can think of them. Did you think about construction industry? I hope so. Take a closer look at this. Do you recognize some of these other metals? You'll want to think back to your chemistry class and think about some of the metals on the periodic table. A lot of these are transition metals, right? Some are not. What are some things here that you recognize, and what are some of the uses of them? On the right side, you'll notice that you have a number. Those are the metallic equivalents in thousands of metric tons that are being extracted for use. Now this data is a little bit dated. It's from 1998. But I think it still gives us a good feeling for what some of the major natural resources are and how much of those resources we're extracting from the earth. Let's move on to the next slide. In this slide, we're going to talk about new techniques that are being used to supply demands that the world has for various natural resources. Are those new techniques safe? And what do we know about them? Let's consider what's shown here. One of the skills that you're really going to be brushing up on this year is the skill of reading graphs and charts and tables. And those of you that are juniors know that that skill is very important to you if you think forward to April when you'll be taking the PSAE testing and especially the ACT test. Now the science reasoning portion on the ACT test contains many diagrams, such as this one, which ask you to really look at what is being shown numerically and what those numbers mean. As we continue to look at this slide, I'm going to ask you to think about the answer to the question that's being asked here. So the question is, what new technique is being used to supply this demand? Demand for what? This graph is showing the worldwide demand for natural gas. And it shows two numbers for each of the different regions. A demand in the year 2000 and a demand in the year 2010. The numbers that are shown here are in billions of cubic feet per day. So just take a quick look. Which region of the Earth demands currently the largest amount of natural gas? Secondly, which region is projected to demand or is demanding in 2010 the largest amount of natural gas? How much did that demand increase during that 10-year period? For which region did the demand increase the most between 2000 and 2010? Look carefully. Back to the technique that's being used. The new technique that's being used is a technique called hydraulic fracturing. You may have heard it called fracking for short. When we study natural resources later this fall, we'll be talking more about the process of fracking. We'll want to know if it's safe. We'll want to know what you already know about fracking and see what's being talked about in the news. There are some concerns related to fracking, to extracting natural gas through this process called fracking, and we'll be learning about those in the future. Let's move on to this next slide. This slide will give you a pretty good idea of what you as an individual will be using throughout your lifetime. So here's some interesting data to consider regarding mineral demand and use. Every American born will need 2.96 million pounds of minerals, metals, and fuels throughout their lifetime. take a look at what some of these things are and the amounts of them that you will need. And then I'd like you to pause this recording and take a few seconds to write down what some of these things might be used for. Which ones do you know you use on a daily basis or maybe a weekly basis? And in what form do you use them? So here's an example. Right above the baby's head, you can see listed 32,796 pounds of salt. Now we can all think of some uses that we have for salt. You put it on your food. You put it on your driveway in the winter when it's icy. That would be a good thing to write down. So I use salt pretty regularly, and here are two things I use it for. Might want to write that in my notes. So take a minute here to look at the other items that are listed on this slide. Write them down and write what you use them for. This will help you later as you think about mineral resources or natural resources that you use. Go ahead and take a couple of minutes to do this. Pause the slide here, please. Start it again when you're ready. If you had trouble on the last slide, I think this slide will help clear things up for you a little bit. So we have some more interesting facts here about natural resources that we use. And I think it's a really good thing to start to think about, how are these natural resources identified? How do we find them? Who is it that's doing the work of finding these things? We know there are miners that are out actually doing the extraction, but who is it that actually finds the deposits of these resources? The mining companies? Who within those companies? Who goes out and does the exploration? Well, these are geoscientists in every situation, and this might be an area that you'd be interested in thinking about down the road as a career. Do you love to work outside? Do you love challenges of looking for things and finding things that are going to be useful to society? Think about these things as you're continuing to look through this slide. But there's an interesting fact up at the top. Every year, 38,052 pounds of new minerals must be provided for every person in the United States to make the things we use every day. Here's a list of some of the things that we saw on the previous slide, and this one gives us some information about what some of these things are used for. So take a look at this list. Look back at the list from the last slide that you made, and let's see what you got right. I think you'll find out that you knew more about this than you thought you did in advance. And if you learn some new things about some of these resources and get some insight into what's being extracted from the earth and how it's used, that's a great thing too. You're going to want to pause the slide here again for a moment as you look forward and back and consider these different resources and their uses. As you were starting to think about our demands for these various resources and starting to think about where they might come from and who might do the work of identifying and extracting them, did you start to think about the United States and wonder what percentage of each of these resources we're actually finding in the United States and what percentage we need to import? Well, this slide will help us understand the global nature of these demands. So how is our demand being met? This data is from 2007, and it shows us here the net import reliance that the United States had on selected mineral materials. In the left-hand column, you'll see the actual resource, the commodity, the product here. Next to it, you see the percent that has to be imported into the U.S. to meet our demand. And on the far right, you'll see the major import sources from the years 2003 through 2005 for each one of these products. So look down the list. Let's stop at the third item on there, bauxite and alumina. Bauxite is a mineral that you'll look at when we study natural resources. Bauxite is the primary ore for aluminum. And this graph tells us that 100% of the bauxite that the U.S. demands has to be imported, and that it is imported from Guinea, Jamaica, Australia, and Brazil. What other minerals on this list or resources on this list do you recognize? Where are they being imported from? If you quickly scan the list of major import sources, I think you'll quickly realize how global this mineral resource or natural resource economy is. There's a good reason why these products are coming from other countries. They have economically viable deposits of each of these, meaning companies can make money by extracting and selling them to other countries. Now, one thing you might think about as you're thinking about things like aluminum and tin is you might think about recycling. So in the United States, there's a big drive to reuse and reduce and recycle. What role does recycling play in our demands for natural resources? Well, this slide will give us some good information about that. Let's take a look. Let's start out by treating this slide as a graph, which it is. So let's look at the title of the graph first of all. The title of this graph is U.S. Raw Non-Fuel Mineral Materials Put into Use Annually Between 1900 and 2006, excluding materials embedded in imported goods. Now let's look at the axes. So on the y-axis, we have millions of metric tons of the different mineral materials. And on the x-axis, we have time from 1900 through 2006. We have 4 different commodities represented on this graph. They are primary metals in yellow, shown at the bottom, recycled metals, shown in purple, industrial minerals, shown in peach, and construction materials, shown in tan. And then there are some key times shown with arrows pointing to them on the graph. So we can see the impact of events such as World War I, the Great Depression, World War II, the oil crisis of the 1970s, I think it's interesting to take a look at the construction material trend and think about it in terms of the history shown here. So what happened as a result of the Great Depression? What happened during recessions to the amounts of construction materials that were required? That's interesting to look at, but more important for us to look at here is the recycled metals portion of this graph. And that's that skinny purple line way down at the bottom. So as you're thinking about the demand for these natural resources and you think, well, maybe lots of what we're doing in terms of recycling is having an impact on that demand, take a look at this graph and think further about the impact that we're having. Can we do more as a society? I think we can. So are you ready for your quick mastery check for the section on natural resources? Here it is. List at least 5 natural resources that are geologic in nature that are contained in products you use on a regular basis. So you'll want to list those natural resources and list the products that they're used in that you use. I hope you enjoyed this section of the informational workshop. The next section, we're going to be talking about the nature of Earth. We'll be looking at some landscapes and some other interesting things. See you for the next section. Welcome back to the third part of the informational workshop for Chapter 1, An Introduction to Geology. As I noted in the second part of this series, this chapter is really an overview of much of what we're going to be studying throughout the year. It introduces you to some vocabulary that will help you understand different topics as they come up throughout our school year. During this section, we'll be talking about a couple of key vocabulary terms and thinking a little bit about deep time or geologic time. We're going to start out with a couple of kind of tough vocabulary words here. The first of those is a term called catastrophism. Now, when you hear the word catastrophism, I bet you hear the word catastrophe in that longer word. Catastrophism is the belief that Earth's landscapes have been shaped over time by great catastrophes. So here's a good question. What are some examples of catastrophic events that have had an impact on shaping Earth's surface, Earth's landscapes? Now let's start with the one that's shown here in the picture. If you've ever been lucky enough to travel out to Arizona, you may have gone to a place called Meteor Crater. Meteor Crater is just that. It's a location where a large meteor impacted the surface of the Earth, leaving behind a crater. On the left-hand side of the picture, you can see the road leading up to the visitor center. And if you look closely at the picture, around the rim of the crater, there's actually a trail about 3 miles in length that encircles the entire crater. The impact of a large meteor such as this would certainly be a catastrophic event, and you can see that it had a major impact on Earth's surface. But the question is, what are some other catastrophic events, events that happen in very short time frames, that have a major impact on Earth's surface? You're going to want to pause this video just for a couple of minutes and think about the answer to that question, and jot your ideas down on your notes. Go ahead and pause this. Moving on to the second term. Our second term is uniformitarianism. This is a term that was coined by James Hutton. And the term uniformitarianism describes forces and processes that we can see shaping our world today that have been at work for a very long time. You'll often hear uniformitarianism described as the present is the key to the past. So let's ask this question. What can you see in this picture? What are the processes that are happening or visible in this picture that are actually shaping the landscape we're seeing? So in the picture you can see a deep river valley, a canyon, and you see a river flowing through that canyon. Additionally, you can see some sediment deposits within that river, and you can see a little bit of the trace of the current of the river. So can you describe, with the idea here, the present is the key to the past, how uniformitarianism is shaping this landscape that we see in the picture? Take a minute and write down your thoughts. I'm guessing that you probably said something about the river water flowing over the rocks and picking up little grains of sand or other sediment, gravel perhaps, carrying that sediment along down the river channel. And as this process continues, it deepens and widens that river valley. And that's exactly what's happening here. But there are other processes at work in an environment like this, processes such as mass wasting that we'll be talking about later in the year. So what are some examples of ongoing processes that have shaped Earth's surface? Other processes, for example, think about our local environment. What are some of the processes at work outside in our local environment that are creating our local landscapes? Again, you're going to want to pause this slide for a moment as you think about your answers and jot them down on your notes page. Okay, so here's our quick mastery check for catastrophism and uniformitarianism. Your task is to make a Venn diagram for these two terms. So let's talk for a second about Venn diagrams. Venn diagrams have an overlapping area. That's where you would list any features or components that would be common to both the end members here being catastrophism and uniformitarianism. So you can treat this in a couple of different ways. You can list some examples of catastrophism, some examples of uniformitarianism, and look for some crossover between them. That'd be a good start. So you're going to want to pause this video as you do this work, and then rejoin me as we delve into geologic time and deep time in a moment. I hope you're ready to think about long periods of time. Now, it's easy for us to think about a year since your last birthday or your sophomore year of high school as being a long period of time. But in fact, the amount of time that humans have even been on the Earth is relatively short. So we need to think of things in kind of a different frame here. Now let's get started on thinking about that with a couple of questions. What are some really old things beside your teachers? And how old are they? So here we have three pictures to help us start thinking about that. The picture on the left is a picture of a bristlecone pine, and this pine is over 4,000 years old. This pine actually stands on the slopes of Pikes Peak out in Colorado, near Colorado Springs. And if you get a chance to travel out to Pikes Peak at some time and you take the old cog railway going up, you'll have a chance to see this bristlecone pine tree, along with some of its younger cousins living nearby on the slopes. 4,000 years is very old. But when we start to think about deep time and the age of the Earth, and how long some processes on Earth and in Earth take to happen, 4,000 years isn't long at all. Now, next to the picture of the bristlecone pine, you can see a picture of a creature that is alive today. Now, this is called a nautilus, and he's actually a really unique creature. I encourage you to hop out to YouTube here and look up a picture or a video of nautilus and just see how he swims. He's really quite a fascinating guy. But in fact, the creatures like the nautiloids or other cephalopods have been on Earth since early Ordovician time, which is over 400 million years ago. Now, just to get a really good feeling for how old that might be, you actually might want to write the number down, not 400 and then spell out million, but write down 400 million with all those zeros. Get a feeling for how long ago that might have been. So there are creatures that are alive today on Earth whose early ancestors evolved many hundreds of millions of years ago. And in the bottom right corner, you can see a picture of a spiral galaxy. Now, each one of those points is actually a star, much like our own star, the Sun. And we get a feeling for the immensity of the universe. But do we get a feeling for the deepness of time when we start to talk about billions of years, maybe 14 to 15 billion years as an age for the universe? Now let's think further about some locations that are a little bit closer to home and about ages. So here we see a picture of Central Park in New York City. So on the island of Manhattan, there's a huge park in the middle, that's why it's called Central, in the middle of New York City. And in that park, there are some rocky outcrops, and you can see a picture of these people standing on top of these rocky outcrops. Now here's a good time to stop and write down this vocabulary term, the term outcrop. And you're going to encounter that word numerous times during the school year, but the first time that you will actually experience an outcrop in class is when we go on our first field trip later in September, and we'll be seeing some rocky outcrops of Silurian dolomite as we walk through a canyon at Camp Sagawa in September. So the questions here are, how do we know how old things are, and are there different ways to express ages? Well, when you're in a place like Camp Sagawa, where we'll be on our field trip, looking at a Silurian dolomite, or you're in a place like Central Park in New York, standing on top of this rocky outcrop, You might want to know how old those rocks are. And how do we know how old they are? And are there actually different ways to determine their ages? One of the early ways that scientists tried to express ages was through something called the geologic timescale. And we want to think about some of the underlying concepts of the construction of this geologic timescale. Let's take a look at the picture that we're seeing here and think about how the geologic timescale might have been constructed. What observations did scientists make, and what information and data did they use to try to construct this timescale? Let's think for a minute about the way that we divide time. So we divide time into class periods, or days, or weeks, or months, school years or calendar years, years combined into decades and centuries, kind of arbitrary divisions that we place on time. Let's think about this a little bit differently. Could we think about it based on events that have taken place? Could we think about it as being maybe a division called the World War I era, the World War II era, the Vietnam era? Might we think about it as in Gen X, Gen Y, millennial generation? Lots of different ways that we can think about timescales. And similarly to that, we can think about the timescale for the Earth's history. And if you think about a timescale for the Earth's history, you might find that it would be reasonable to divide Earth's history into segments of time based on some specific occurrences. Before we develop this idea a little bit further, let's think about some vocabulary terms. The first one is going to be the term fossil. Now, I'm not sure what comes to mind for you, but I'm kind of betting that some of you might be thinking about dinosaurs as being fossils. Well, the definition of a fossil is that a fossil is something that represents the remains of a once living organism. So it doesn't necessarily have to be a big, huge dinosaur. It could, in fact, be a little tiny multicelled marine animal, or it could be an imprint of a leaf. Many different things qualify as fossils. Most fossils are the remains of extinct organisms. That is, they belong to species that are no longer living anywhere on the Earth. And the kinds of fossils that are found in rocks of different ages differ because life on Earth has changed through time. So that's a pretty profound statement. If you think about it, that means that we could take a look at rocks from different ages, find different organisms fossilized in those rocks, and we could start to divide up Earth's history based on the different kinds of fossils or different kinds of life that existed, and then try to make a sequence of those different kinds of animals or plants, flora or fauna. And that's exactly what we see in this diagram. So let's take a look. The column on the far left is entitled Period. So these are different periods of time. The most recent period of time being listed at the top as the Quaternary, and the oldest period of time in this diagram listed at the bottom as the Cambrian time period. The time periods in between, from Cambrian to Ordovician to Silurian, progressively get younger up until present day. The second column gives examples of some of the animals that lived during those time periods or during multiple time periods. So you can see the first example there, animals with shells, began as early as Cambrian times, and we know that those animals with shells are represented throughout the entirety of geologic history through to the present day. We can see the next group of animals that evolved were fishes. They evolved towards the late part of the Cambrian and of course exist today. followed by amphibians, reptiles, mammals, birds, and finally humans. What do the black lines represent next to each of the names? You'll want to make sure that you understand this. Now compare those to the different types of plants that existed throughout geologic time. And you'll see here the evolution of different types of plants from Cambrian through till present time. For example, during which period were pines first observed in the fossil record? And during which period did the first flowering plants come into being? Take a close look at this. We're going to have a mastery check coming up soon. Do you understand the geologic time scale? Let's take a look. Here's your quick mastery check. In this picture, you can see a more complete version of the geologic time scale. Here we have eons, eras, periods, which we already looked at, epochs, and we also have some times given in the column to the right. Now, the MA at the top stands for millions of years ago. So which part of this geologic time scale shown here is most recent, and which part represents the earliest portions of the Earth? Here are the questions for your quick mastery check. Are the lengths of time consistent for each epoch? Are they consistent for each period, each era, and each eon? You'll want to write your answers to the right of this slide. Next, are there a consistent number of divisions for each epoch? And finally, why do you think there are fewer divisions for older time periods and eras than the more recent ones? As you try to answer this question, you're going to want to think back to the reasons that different periods were divided up as they were. You're going to want to pause here as you take care of this quick mastery check. When we come back, we'll be taking a look at the origin of our solar system.